Hello, you're welcome to today's physics class. And today we will be talking about calculations relating to motion. We're talking about calculations relating to motions, and at the end of today's class, um, you will be able to carry out calculations, have the ability to understand several conversions and even parameters identification. These are the things that we will be talking about today, and we'll also be carrying out calculations on motions horizontally and vertically. So, I feel that you sit back and listen, and just also take your notebooks, and so that you can actually jot down some things as we try to enlighten ourselves on the topic of motion. So, what exactly is motion? Motion has to do with the change of position of an object with respect to time. Yes, it has to do with the change of position of an object with respect to time. So, now let's start. When it comes to equations of motion, there are different equations of motion that we do have. And I would give you, considering the horizontal axis and considering the vertical axis. That means, if you're talking about a sideways kind of motion when it's moving from one point to another sideways, or we're talking about a kind of motion that has to do with from up to down, like going up to down. So that's vertical and this is horizontal. So now if you're talking about it vertically, if you're talking about it vertically or horizontally, if it is vertical, we are going to be working with what we call the G. Our acceleration will be represented as G. That is acceleration due to gravity. But if you're talking about it horizontally, our acceleration will be represented as A. Now, if we are about to start giving the equations, then if you're talking about distance, our distance, if you're talking about it horizontally, will be represented as S. But if you are talking about it vertically, it is our distance will be regarded as H, which is height. So, without much time taken, let's give our equations. So, if you are talking about it horizontally, if you are talking about it horizontally, let's give the equations. The first one is V is equals to U plus 80. We also have another one as V squared is equals to U squared plus 2AS. We also have another one which is S is equals to UT plus half AC squared. And we also have another one again, which is S is equals to U plus V over 2, and we multiply it by C. Now, let's give these different figures a meaning and their units too. So if you're talking about V, our V is actually what we call final velocity. We call it final velocity. Now, what is the unit for final velocity? The unit for final velocity is meter per second. So when you see a particular, statement, and in the statement you are literally given the figure and you have meter per second there, you should know that that particular quantity we are talking about is velocity. So the unit for velocity is actually meter per second. Now, when we move to the next one, we have u as the next one, and u is indicated as initial velocity. Initial velocity. And please bear in mind that since it is velocity, the unit is still indicated as meter per second. Now, let's move to the next one, which is A. And our A is acceleration. And Since it is acceleration, please also bear in mind that it is not just acceleration, but now let's talk about the units. The unit is actually meter per second square. So please look at the difference. The difference for final velocity and initial velocity in terms of their units. For velocity is meter per second, but for acceleration is meter per second square. Meter per second square. Now, when you let's talk about what S means, and in this case, S is the distance. You can call it the distance covered. It is the distance covered. And what is the unit? The unit is actually meters. The unit is actually meters. Now, let us go to time. And for time, it is actually, the unit is actually in seconds. It's actually in seconds. And please know that the T stands for time, and the unit is in seconds. The unit is actually in seconds. Okay, now let's talk about the vertical distance. Now, if you should talk about vertical distance, we have similar things. It is still similar to what we have here, but there are just little differences. For example, this where you have v is equals to u plus at can be written as v is equals to u plus or minus gt. Why do we have a plus or minus? I will explain that. Now, next one you have v squared is equals to u squared plus or minus again 2gh. And the next one you have, instead of us writing s is equals to ut plus half at squared, we'll turn it to h. We turn it to h is equals to ut plus or minus half gt squared. S is equals to ut plus or minus half gt squared. Now let's give this thing a meaning. Now, why do we have a plus or minus? Now, please bear in mind that our g in this case, our g stands for acceleration, acceleration due to gravity. Acceleration due to gravity. And what does our h stand for? Our h stands for the height covered, or the height attained. Our height attained. Now, this is these are the different parameters and their interpretations. Please also bear in mind that our h here, the unit is actually in meters, and the unit for our acceleration due to gravity is meter per second squared. So anytime you see a question and you see a particular, quantity given, and you are saying meter per second square, you're talking about acceleration. If you're saying meter per second, we are talking about velocity. Okay. Now, let's clarify something here. One thing we should also bear in mind as regards this calculation before I proceed to, examples as regards this calculation is sometimes you see in a question that maybe a car starts from rest. A car starts from rest. And if you hear a car starts from rest, then it attains the velocity of blah blah blah. Now, if you're told that a car starts from rest, please bear in mind that the initial velocity, as far as you have been told that it starts from rest, the initial velocity is zero. It is zero because it starts from rest. So, because when it is at rest, there is actually what? There is actually no movement. Hence, it is said to be zero. So your u in that case is zero. Or maybe you hear that a car was moving at a certain velocity, then it was brought to rest. As far as you hear it was brought to rest, that means that your final velocity, which is your v, happens to be zero. Your final velocity is zero. Now, let's come to this thing here. The plus and minus sign we have here. What does the minus sign indicate? And why should we use a plus? This means or. It is plus or minus. You can't work with both of them. You can either work with plus or you can work with minus. Now, when are you meant to use your v equals to u minus gt? And when are you meant to work with v is equals to u plus gt? When? The minus sign is indicated to represent acceleration, the direction of acceleration or the direction. Now, what do we mean? If you hear that the ball was actually thrown upwards, now, if it is thrown upwards, you should also bear in mind that it is moving against gravity. Hence, in that particular context, your question would have a minus. So your equation will be v is equals to u minus gt. But when you hear that it was thrown and it was heading towards the center of the earth. Now, towards the center means it is moving towards gravity, so it is not against gravity. Hence, it is not against gravity. You can actually carry out your equation by writing v is equals to u plus gt, or v squared is equals to u squared plus 2gh, and so on and so forth. So these are the certain things you must bear in mind before you carry out your calculations. Now we have this, it is time to carry out our calculation. But one more thing before I carry out my calculation is what we call deceleration. Now, what is deceleration? Deceleration is said to be the negative of acceleration. Now, what is acceleration itself? Acceleration is the change of velocity with time. The change of velocity with time. For example, how do you carry out your how is acceleration calculated? It is given as a is equals to v minus u over t. So most of the time it's meant to be positive because your final should be higher than your initial. So v minus u over t. But when your but sometimes there's what we call a negative acceleration, which is deceleration. Now, even though you hear the word deceleration, deceleration still means is still represented as a is still represented as a, but it is a negative acceleration. So most of the time it will have a negative sign. So in the case where you said maybe a car was moving at a speed of 30 meters per second and it was brought to rest. So in that case, you should know that your v is going to be zero, and your u, which is your initial, is meant to be 30. So let's actually start applying most of these things I've been analyzing so that it makes clearer sense to you. Now let's consider this question. A car covered 420 meters in 10 seconds, and the initial velocity of the car was 2 meters per second. Find the acceleration that the car had in its motion. Now, how do we carry out this question? First things first is what? To write out the parameters. Now, if you write out the parameters, you'll be having this: a car covered 420 meters. Now, that means our S in this case is 420 meters because that was the distance it covered. Now, in 10 seconds, that means our T is 10 seconds. And the initial velocity of the car was 2 meters per second. So, since it's initial, we represent initial as U, which is what? 2 meters per second. Now, they said find the acceleration of the car. Find the acceleration that the car had in its motion. So you have your A as your missing parameter. Your A is your missing parameter here. So as I said, you always for you to have a question like this and carry out your calculation successfully, you have to do what? You have to actually look for the equation that rhymes with the parameters here and also have the missing parameter. So you can actually make it the subject of formula. Now looking at this, you have S, you have U, you have T, and you have A. The equation that would perfectly fit for this kind of question will actually be S is equals to UT plus half AT squared, because it has your S, it has your U, it has your T, and it has your A, which you're looking for. Hence, we can comment, and you have a question, and you have something like 420, which is your S. Now, your U is 2, and your T is 10, plus, now we write half, multiplied by your A, which is unknown, and your T is 10. Your T in this case is 10, so, and that means we have it as times 10 squared. times 10 squared. So this can be written as 420 is equals to 20 plus now 100. 10 squared is actually going to be 100. So it is actually 100 times a, which is 100a divided by 2. So this is same thing as writing 420 equals to 20 plus 100 divided by 2 is actually 50. So you have 50a. So what the next thing we collect like terms and you have 420 minus 20 because this is coming over to this side. If the 20 comes over here, the sign changes. So it's 420 minus 20 equals to 50a. 50a. So since you have it as 50a, so what do? You have it as 400 is equals to 50a. Then now to make our a subject of formula, we divide by 50. When you divide this by 50 and you divide this by 50, and 50 divided by 50 is actually, you know, a. That's 50a divided by 50 is actually a. So that means 400 divided by 50 is 8. So this is 8 meter. Now, because of it is acceleration, the unit has to be meter per second squared. So this is actually 8 meter per second squared. That's how to carry out the calculations on acceleration. So let's proceed. Now let's take this question. For example, um, an object is launched upward and attains a maximum height of 300 meters. Find the initial velocity of the object. Find the initial velocity of the object. Now this is it. How are you going to attempt this question? First of all, the most important thing is to write out the parameters and look for the missing parameter, so it makes you understand which of the equations of motion you should actually work with. So if you have a question like this, they said it attains a maximum height of 300 meters. So that means our h is actually 300 meters. Finds the initial velocity of the object. So our missing parameter is u, and our g is actually 10 meter per second square. 10 meter per second square, because they say take it to be 10 meter per second square. Now in this kind of question, this is the kind of question that involves the vertical axis, because you can calculate motion horizontally or vertically. So if it has to do with the one that has to be with the vertical, that of vertical will actually be, you will be using your g's and your h in replacement of a and s. So in this case, we have several equations of motion. So we will be working with v square is equals to u square minus 2gh. Now, why are we working with minus instead of plus? Because it's thrown upwards and it attains a maximum height. So that means that it is going upwards, which is against gravity. As far as your object is having a motion that is opposing gravity, the direction of gravity, your g is meant to be minus. Please bear that in mind. Your g is meant to be minus. And when a ball or an object is thrown upwards and you are told that it attains a maximum height, it means that that moment it has attained its maximum height, the final velocity is 0. Because when it gets to the maximum height, it does not move. It does not move. So these are the certain things you must, put in mind before you carry out your calculations. Hence, we would say that our v is 0. Now we have stated this, we can now carry out our calculation. Now let's start. Since our v is 0, so we have this as 0 square, which is still 0, equals to, now our u in this case is unknown, so it is u square minus, now 2 times our acceleration due to gravity is 10, and our h, and our h is actually 300. Now, when you carry out this calculation, you'll be having u square minus, now when you have this minus
2 times 10 times 300. So this is going to give you 3,000 and this is going to give you 6,000. Hence, you have this to be 0 is equals to u square minus 6,000. Then when you take this to the other end, it becomes minus u square is equals to 6 minus 6,000. Now, minus would actually cancel out the minus. So that means you would find the square root of u square. And square root of u square is root 6,000. And root 6,000 would actually give you 77.459 meter per second. So this is how the question is actually carried out. This is how the question is actually carried out. Now let's look at this question. How long will it take a bike which moves at 72 km per hour to cover a distance of 1,200 meters? So what's the first thing we do? We write out our parameters. Now, it moves at 72 km per hour. So this would happen to be our velocity, and our distance, which is s here, will be 1,200 meters, and we are looking for what? Time, because they asked you how long. So you might not necessarily see a question that said what is the time taken. Sometimes they would ask you how long. So it is up to you to what? Have the capacity to decipher. So for example, if they say how far in a question like this, they're asking you like the distance. But if they ask you how long, they're asking you the time. So please let's get acquainted with that kind of methodology of questions being asked. So now let's look at this. The first thing is we are looking for time. We are actually looking for time. And since we are looking for time, first things first is we have a non-correlation in terms of our units. Our velocity is given as kilometer per hour and our distance is given as meters. So we have to carry out a conversion. So if I want to carry out my conversion from kilometer per hour to meter per second, I have to convert it from kilometer per hour to meter per second. How do I go about it? So my kilometer has to be multiplied by 1,000 to convert it to meter, and my 1 hour has to be converted to seconds. And how do I convert my hour to seconds? In 1 hour we have 60 minutes, and in 60 minutes we have 60 seconds. So that means in 1 hour I would have 60 minutes times 60 seconds, which is 3,600 seconds. So if I am to carry out my conversion properly, I'll be having 72 times kilometer. Now that is 1,000 meters. 72 times 1,000, and if I am converting my hour, it's going to be 60 times 60. So that is equivalent to 72,000 divided by 3,600. And after I carry out my division, I will be having my answer to be 20 meter per second. And since I have it to be 20 meter per second, then I can carry out my calculation. Hence, I am asked how long. So I can work with my formula as S is equals to UT plus half AT squared, or that's actually the best thing to work with here. That's the best thing, because you're having your your distance, you're having your velocity, and you're having your time. And these are the three parameters that are required in this question. Hence, we would start. Now the question is, what is your A? Your A was not given, so we'll take our A to be 0. So in this case, we would have 1,000 200 is equal to our u now in this case has been gotten to be 20 times, and our t is unknown because that's what we are looking for. Then you have this to be plus half at squared. Our half multiplied by, remember I said our a was not given, so it is 0 times t square. Now, even though we have our t is still what we're looking for, but remember that everything in this section here is going to be 0 because they are all multiplied by 0. So it is going to be this plus 0. So you have this to be 1200 equals to 20t plus 0. So what's the next thing? You divide by 20. You divide by 20, and when you divide this figure by 20, you are going to be having your time to be 60 seconds. Your time to be 60 seconds. So literally, this is what calculation involving equation of motion, entails. It's just all about getting their parameters, knowing how to insert it in different equations of motion, and you get your answers. So I hope that you have been able to, understand this topic. And if you really have any question that bothers you and you don't really know how to navigate through, I am always open. You can always indicate the question in the comment section, and that I'll actually analyze it for you. I can even make a video concerning it. So this is where we'll call the class, we'll call it the end of the class, and hopefully you've been enlightened. So I am appealing that you please like and subscribe to the video, to the channel, and hopefully would give you more educative content. Thank you very much, and I remain your tutor, Miracle the Tutor.